So I hope, see, this table is taken from your textbook only. Like you need not specially copy it. And all the diagrams that I'm going to show are in your textbook itself, so that you can have a reference. If you have a pencil, you can make a note there itself. I do not want you to waste time in again making notes, right? If anything is unclear, please ask. So as I told you, right, by the end of day, you will solve this exercise just in 15 minutes. It's that simple. It's that simple. Only theory is a little complicated. See, before I start, right, there are 2 points I'm going to ask. One is inverse of a function. So, what is necessary for the function to be having its inverse? Bijective. 1, 1, and it is supposed to be onto. This is the only thing that I want you to have it in mind. And secondly, how are the invertible functions going to behave? We saw a definition number 9 from yesterday's class. I did a problem and showed also. F circle G and G circle F both will generate what function? They will generate identity function. I'm not talking about Ix or Iy. They generate an identity function. Let's keep it simple, right? And you know how to write the inverse also, right? So basically what will happen is you will have a main function, and that main function is supposed to be what? It is supposed to be a bijective function for it to have an inverse. So that if you do the composition between the main function and the inverse of it, you will get an identity function. Is that clear? Okay. Now see, this is the graph for sin x. The name of the chapter is inverse trigonometric function. So I need to find the inverse of the sin x. So let's first try to understand what do I mean by inverse in the first place, right? If I give you a function like y is equal to sin x, listen to this carefully. I'll speak in terms of input and output. So what will be the input value you will feed to it, and what is the output expected? Input value you are going to feed is an angle, and the output will be a value, some real number, right? See, for example, I'll ask you what is sine of pi by 2. So pi by 2 is an angle. When you feed this data, what will this operation give you? The answer will give you, it will give you a 1, right? So input is an angle and output is a value. So if I call y as a function which is defined from, how do I write it in the domain and codomain form? Y is a function which is mapped from real number to, what is the codomain of this? Codomain is, you get real numbers here, okay? Codomain is real number, right? If I write this function y is equal to sin x as a function mapped from R to R, in this scenario, is it an invertible function? Y is equal to sin x when f is mapped from R to R. Is it an invertible function? So think one by one. Don't put both the things and confuse yourself. First thing is, tell me whether it is going to be a 1-1 function. You have the graph in front of your eyes. I've already told you what is horizontal line test. Obviously not. When you draw a horizontal line, the horizontal line is cutting the curve at more than 1 point. It is not 1-1. Secondly, is it onto? Is it onto? No, because the codomain says real number, but what is the least value that you can get? -1, and the maximum value you can get is 1. So to make it a bijective function, I understood that I need to do some change with respect to the codomain. Okay, accepted. What change should I make to the codomain? If I make f is a function mapped from something, I don't know, I'm not doing any change with the domain as of now. Something mapped to -1 to 1. Okay, this -1 to 1 is telling me that it has become an onto function. Am I right? Now it has become an onto function because codomain is equal to range. But what should the change? What should be the change I need to make on the domain part for it to become a 1-to-1 function? For that, what I'll do is, I'm looking at this graph. Are you able to observe a pattern in this graph? So you see a pattern here. Yeah, that is there. So you see a pattern here. Yesterday I used one word, if you remember. I used a word called as increasing or decreasing function. Do you remember? I used a word like that. You know what is increasing, right? I told you like this. So if I take a graph like this, if the graph is like this, see, for example, I'll take this parabola, okay? I'll take this parabola. What is the equation of this? Y is equal to x square. Y is equal to x square. It's an upward parabola. Now, if I ask you from minus infinity to 0, tell me what is the nature of this function. Is it decreasing or increasing? Look at the graph and tell me. It is decreasing. From 0 to infinity, it is increasing. So, whenever a function is decreasing and then increasing or increasing and decreasing, it cannot be a 1-1 function. So, to make it a 1-1 function, what I should do is I should create a restriction on its domain. So, what I can do is I can make it a 1-1 function if I restrict its domain either from minus infinity to 0, or I cannot do both of them simultaneously, or 0 to infinity. If I do either of them, if I create this kind of a restriction, then how will the graph look like? If I do a restriction from minus infinity to 0, I'll draw only this part. If I do a restriction on 0 to infinity, I'll draw only this part. Meaning, I'm breaking the same graph into two parts. Are you able to visualize what I'm saying? Right, I'm breaking it into two parts so that each part is considered to be a 1-1 function in its own domain. In a similar way, this graph being like this, right, in the form of a wave, if I have to create a restriction on its domain, I need to choose a particular region around the origin. Listen to this carefully. I need to choose a particular region of the graph around the origin where either it is completely increasing or completely decreasing. If I have to see that, I am able to see from here till here. Meaning, I'll erase all these parts. I'm not concerned about it. If I do that, I hope this part is clear. So what was the initial function we defined? It is sin x only, but where did we define it from? We defined it from real numbers to real numbers. But to make it an onto function, what is the restriction I made on the codomain? I chose only between -1 to 1 because the range will be equal to the codomain. But what should be the restriction I should create on the domain part now? You look at it. So minus pi by 2 to pi by 2. If I create a restriction like this, meaning if I change the function from r to r as minus pi by 2 to pi by 2 to minus 1 to 1, and if I define y is equal to sin x, then what happens to this? It becomes both 1-1 and onto. Hence, inverse will exist for the sin x only under this scenario. Am I clear with this? This is what we call it as restricted domain and range. Did you understand why we are creating the restriction? Yes? Okay. See, for my satisfaction, I want you to think for this cos x and tell me. Look at the graph, take your time, don't confuse yourself, tell me. So this cos x is there. For this one, how do you think the function is defined from? F is defined from R to R. Let's say R to R for instance. If I define from R to R, if I have y is equal to cos x, is this function a 1-1 function? Why? Because if I have to speak in a more matured way, I'm saying the function is increasing and decreasing. I'm looking at the graph. So whenever you have increasing and decreasing thing, you will have a wave-like structure. Right? It's not 1-1. So for me to make it 1-1, I'll think at the end. Is it onto? For onto, what will you check? You will check the codomain part. So codomain is R, but what is the range? -1 to 1. So create a restriction on the domain and codomain so that this first becomes a 1-1 and onto. So something tends to, what should be the restriction I should create? And what should be the restriction I should create on the domain? Look at it. 0 to 0 comma pi by 2. This part. So what is happening here? Is it decreasing? Is it completely decreasing or completely increasing? So it is decreasing, it is reaching a minimum value and then increasing again. No. So what should be the restriction I should create on domain? You are right. 0 is included, pi is included. Why did I include them? Because at 0 and pi, it is giving me a finite value. If it is giving me an infinite value, then I will make it as an open bracket. See, this is what I'm discussing is a whole chapter. Okay, listen to this carefully. Okay, now we are talking about, now if I write this y is equal to cos x, what will happen? This will become an invertible function. because it's bijective. Am I clear with this? Right. First, we'll talk about the restricted domains that are being created on the trigonometric functions. Then we will come to the inverse trigonometric functions. Okay. Look at this graph. Tejas, you're expected to answer this. You are the one who asked no the question. So f is mapped from R to R. Y is equal to cosecant x. So this is the graph. Look at it. So f is mapped from, first I make it an onto function. To make it an onto function, I'll restrict the range. Okay, you want to write it as 1 by sin x. Tell me. No, leave out this 1 by sin x. We already know this. First, tell me what should be the range. R to R night is not 1 1. Sorry, it is not onto. Look at the graph. Minus infinity to. See, there is a break here. Concentrate. Minus infinity to minus 1. Don't use the word comma. Say minus infinity to minus 1. Which one is closed and which one is open? Union. Sai Kalyan, be ready for next question. Union 1 to infinity. Am I right? So when you do this, what will happen? Codomain will be equal to range. Right. Now what should be the restriction I should create on the domain? Only he is going to answer. Yes. You need to look around the origin. You need to look at the points around the origin and see where it is decreasing and where it is increasing. So if you see the graph here it is decreasing. Here it is decreasing. So tell me, what is this value of x? Minus pi by 2 to 2 plus pi by 2. Should I close it or open? Close both. What should I remove? Minus, what is the point at which I am getting infinity? Illa. What is the x value at which the y value is going to infinity? Minus 0. Now you understood, no? That's it. Is the point clear? So if I create a restriction like this, it will become a 1 1 and onto function. So till here, I want you all to copy it first. Which one? No? This part? It's decreasing only. Coming down, no? I am removing 0. In a cosecant 0, what is the value going to give you? Cosecant 0 is giving you infinity. So remember, in domain, you should remove all those values which generates the y value to be infinity. That is the meaning of domain. Domain, right, is all the input values for which you get a finite output. So this function cosecant will it give an infinity or not? Where will it give infinity? When sine is giving 0. Where will sine give you 0? At 0. So between minus pi by 2 to pi by 2, which value should I remove from the domain? That is why I removed it. But at minus pi by 2, what is cosecant minus pi by 2? It's minus 1. What is cosecant pi by 2? It is plus 1. Those are finite values. That is why I put them within the closed bracket. 0 is excluded. Okay. I'll tell you what exactly they will do in school. Listen to this. I know what will happen. They'll give you that box. Memorize it. You will forget. 2 months you will remember. 4th month you will forget. Before exam you will be under pressure. So I have to teach this as a theory subject. So please concentrate. Initially it will be difficult only because 11th standard I don't know what happened. I don't want to comment on it. Another cadence. So listen to this carefully. Wherever you have doubt, please ask. Okay, I'm ready to repeat multiple times also, but ask. Okay, so first 3 points alone, copy it. So you can write down the heading as restricted domain and range for the trigonometric functions. Restricted domain and range for trigonometric functions. Write down that heading and you start preparing this table. Yes. If any, you can take around other points also. It will be symmetric, but generally we take it around the origin because that's how we define it. So, for example, I can restrict it instead of minus pi by 2 to pi by 2. Can you tell me where is the graph appearing similarly? Here, 3 pi by 2 to 5 pi by 2. I could have taken that also. But that will not be the principal domain. They use a word called as principal domain and principal range. Principal na where the graph is appearing in that format for the first time. For the first time, obviously, it will appear around origin. Another, we choose that point. எங்க decrease அந்த bookல you have the diagram and textbook, so you open and show it to her. You ask me from அதுதான் சரி எங்க decrease சொல்லு கரெக்ட்டா இல்லையே always you should go from left to right. When you go from left to right across the x-axis, you need to see whether the graph is falling down or increasing. புரியுதா நீ leftல இருந்து imagine yourself walking. Okay, when you're walking, are you able to see the steep coming down or is it going up? இது increasing. இதுக்கப்புறம் இது increasing. As you are moving, no, இப்போ இங்கேருந்து ஒரு லைன் வரைஞ்சிட்டே போனேன்னா the y value is increasing. That is the meaning of increasing. Okay, just to explain you the meaning of it, right? Simple. இது இருக்குல்ல imagine you're here, okay, you're walking like this. When you walk like this, let's say there are multiple drop downs from here. So how are the drop downs? How is the length of the drop down coming? Decreasing. Another decrease. இங்கே கூட அப்படிதானம்மா it is coming down in the negative direction. So more is the value of negative, more is the lesser the value. Am I clear, guys? See, this part, has it got registered? Did you understand how did I write this minus pi by 2 to pi by 2 and minus 1 to 1? Why did I do that? Just tell me. So why are we restricting the range? To make it an onto function. Why are we restricting the domain? To make it a one-to-one function. Is it clear? So this combined effect will make it a bijective function. Right. So I hope you wrote the consolidated values for the three functions. So what? Which one is open? Which one? There are both. You tell me where you have your textbook. Just look at the graph and you tell me. For range, you imagine you are walking along the y direction. For domain, you imagine yourself walking along the x direction. So for range, you tell me. You look at it and try. Even if it is wrong, it is fine. Try. Where is the least value? Where is the graph going? Down till where? Is it touching the y-axis? When it is not touching the y-axis, it means either infinity or minus infinity. So what is the least value you are able to see in the denominator, in the downward direction? Minus infinity. My infinities are never included, so it's open bracket. So when you keep walking upward, when you're walking from minus infinity or walking in the upward direction, where is the graph taking a bend? At 1, minus 1. So minus infinity to minus 1. Minus 1, is it a part of the graph? It's a part, no? So that should be in the closed bracket. Union means or. Where is the graph starting? There is a break. Where is the break taking place? Between minus 1 to 1. So again the graph is starting from 1. So that value will you include or not include? Union 1 to where is it going up? That's the reason. But see, that's taught generally, but it's actually not cancellation because they are not reciprocals of each other. I told you, no, there is a difference between actually you're not cancelling, you're doing this operation. That is why you're getting that x. It is actually the composition of functions. Basically, f badala sin, g ku sin inverse x. What they will say is cancel this and this, you will get x. Actually, you're doing the composition of them so that you're getting this identity function. Cancellation பண்ற meaning என்ன? It is reciprocal அர்த்தம். See, they didn't teach you functions, they went to continuity differentiability. There they will explain it like that for simplicity. But actual meaning is this. Cancellation கிடையாது. புரியுதா நான் சொல்றது? You are able to understand what is the difference between reciprocal and inverse? Right? You'll learn about this inverse in multiple places. So have this in your mind. Am I clear, guys? See, we are supposed to go to the inverse part. Now, can I go a little fast? Yeah. Sai Kalyan, ready to try? So, what is the function? Even if it is wrong, I don't mind, tell. So, how do you define? Generally, I can define it from R to R. R to R, it is defined. Okay. Y is equal to secant x. Right. So, first make it an, I'm putting a condition, make it an onto function. Abhina, on whom will you create the restriction? On the codomain. You are right. So, what is the range? Graph per. Look somewhere around the origin. Okay. If origin lay, you are seeing the graph here. How is the graph? It is decreasing and then increasing. So, you should, if decreasing and increasing, as you keep going away, is this part increasing or decreasing? Idu par, nalla par. Increasing, correct? So, if I take it like this, okay, I'm sorry, it's my mistake. I told the restriction on codomain, right? So codomain, you have to go from the, you have to walk along the y direction. Imagine yourself here, you're starting from the bottommost point. Where is the graph going in the bottommost direction? Minus infinity, very good. And you're walking upwards. Where is it stopping? It's stopping here. What is this value? Minus 1. Union, there is a break here. It starts at 1 and it keeps going till infinity. So this is going to be the restricted range. What about the domain? Hari Raghav, can you try? Try. So look at the points around the origin. Right. So can I include the 0? 0 I am getting a finite value now. So you are walking along the x direction. So 0 to 0 to here at pi by 2 it is going to infinity. So that value should be removed. So 0 to in the direction of para. What is this value? So 0 to pi close bracket, and from there what value should I remove? The value which is leading the y value to pi by 2, sorry, infinity. So I'll put pi by 2 here. Okay. Did you write the 3 values? See, for example, for sin x, what is the restricted domain and range? F map from minus pi by 2 to pi by 2 minus 1 to 1. What about cos x? 0 to pi to minus 1 to 1. What about tan? We didn't write it. We saw for cosecant. No, so for cosecant, what did we write? Minus pi by 2 to pi by 2. From this, you are removing the 0 and it goes till minus infinity to minus 1, union 1 to infinity. Right. So, what about secant x? F is mapped from, what is the restricted domain? 0 to pi, from which you need to remove pi by 2 to minus infinity to minus 1, union 1 to infinity. Is that point clear? Now, if you observe the pattern, right, if you see the interval size, meaning if I take the length of the interval, everywhere it is pi only. Is it not pi everywhere? Minus pi by 2 to 0, what is the length? Pi by 2. 0 to pi by 2 is pi by 2. Add both, it is pi. Here, 0 to pi, pi. Here, pi, pi. Everywhere it will be like that. Everywhere it is taken like that because we have taken the point around the origin. Okay. So having said this, right, I hope you have already made a note of this. Right, you already made no? Okay. So having said this, how is it going to look for tan? It's very simple. So f is initially mapped from R to R. Pranav, tell me, what is the restricted range? Range is along the y direction. R only. You're right. So it is R only because you are getting every value between minus infinity. It is continuous. There is no break. And how is the graph? Is it increasing or decreasing? Increasing. It is increasing, right? Then what about the domain? Minus pi by 2 to pi by 2. But should I put it within open bracket or closed bracket? I should put it within open bracket because tan of minus pi by 2 will give me minus infinity. So whichever x value is generating an infinite value, that value should not be included. I hope you are getting clarity of where to use my open and closed bracket. I repeat it, this is very important for a topic called as increasing and decreasing function. Whatever I am discussing will come in calculus again. At that point, you should know where to use open and closed bracket. Anale pay doubt in that you ask it. Is everyone clear with this? Can I assume is everyone clear where to use open and where to use close? Okay. Elma. 0 to pi minus pi by 2 எடுத்தனா here the இது இப்படி வருது அப்படி எடுக்க முடியாது ஏன்னா around the origin what is happening is it is symmetric. No, see there is something called as even and odd function also. I don't want to introduce too many terms. This is an odd function. So odd function க்கு எப்பவுமே பார்த்தனா you should see on the first quadrant and the third quadrant. நான் எல்லாம் முடிச்சதுக்கு அப்புறம் ஒரு பேட்டர்ன் சொல்றேன், but you will easily understand. But is the theory clear till this point? For this also, if you see what is the range, I mean, what is the class interval size? It's still pi. Okay. And lastly, what do you have? You have cot. So f is mapped from R to R, right? Vaishnavi, can you tell me what is the restriction I need to create on the range? Sorry, on the codomain for it to be equal to the range? Real number. What about the domain? இல்ல அதுதான் எழுதிட்டேன். டொமைன் கேட்கறப்ப இங்க பார்க்கணும். பார்க்காத அப்படி. Where is it continuously decreasing? Where is it continuously decreasing? So 0 to pi, but should I use an open bracket or a closed bracket? இதுடா இந்த மாதிரி. இங்க என்ன ஆகுதுன்னா இங்க டிக்ரீஸ், இது கூட எடுக்கலாம். But we will take somewhere around origin. Okay, and mostly you will not try to include the negative values because I use the word principal. அதுதான் வரும் உங்க டெக்ஸ்ட் புக்ல பாரு, principal range ன்னு இருக்கும். That's what every question asks also. I told you in the first exercise they'll ask you the principal range only. Principal another something that is appearing for the first time. It will appear around the origin. So what should I write? 0 to pi. இது வரைக்கும் clear? So open போடணுமா close? Open, because cot 0 is infinity, cot pi is minus infinity, infinite value, so excluded. Is this point clear? Okay.